Hi, I want to talk a little bit about breakaway, which is probably the number one cause for casting failure when working with resin. So when you've got a ring and you're going to put hole marking inside of it, this is one of the primary things that will cause failures. When you burn out resin in its initial transition phase between 0 and 150 C, it expands and then it contracts, and then very fine things can break off. That's the first issue. When I say break off, literally the letter breaks off and goes flying around the ring. We'll get into that in a second, right? And then the second reason can be because the writing's too deep. When the metal actually floods in through the gate in the bottom, it has to flood in really fast. Otherwise, it cools down before it reaches the top of the ring. So there's a massive velocity flying through the bottom of the ring. And generally, engraving is going to be at the bottom of the ring, right in the way of problems, right in the way of where that metal has to come in. And if the engraving is too thin and too deep, it can break off and then it goes flying around. And because the powder has lower density than gold, it sits on the outside of the ring and it looks like porosity. Technically, we call that breakaway. So let's talk about some ways to try to limit that. All right. So everyone's got a different way of how they put their hallmarks in. My way is to make these little things. I save them in a file. They are my surfaces I'm going to flow to. You can create that quite easily. Just use a rectangle from center. Start at 0, and then just draw out a shape that more or less is where you normally have your where you would normally have your engraving, right? Take that shape, project it onto the ring, and project onto the ring. There we go. And then explode this and sweep it. Right, then you've got a surface that fits your ring surface exactly, and your rings are more or less the same. You could just keep reusing the same surface. So I'm just going to go Control Z, right? Once you've swept that ring, you can use Create UV Curve. So you create UV Curve on that. Create UV Curve, which will give you a new little surface that you can patch, and then you can draw on this and flow it back to the ring. All right, so that's the construction that I use. You can then eliminate the ring and keep these patches, your three little patches, wherever you want them. You can rotate them around the ring to where you normally use them. And it makes the rest of this process really easy, right? So I've just got a few things, and I'm going to show you the wrong way first, right? So I'm going to grab this PJM. I'm going to extrude it. Let's first get a measurement, right? So when we tell you it needs to be half as deep as it is wide, find your average letter width, which is going to be like, let's say, the P here. Okay, get drafting, get a linear dimension on the drafting, and go across the width of the letter. So this is like the wall that the letter is going to be, right? I'm going to move that up there out of way. We'll use it a little bit later. Right, I'm going to extrude this. Let's grab all of them and extrude. We're going to extrude solid, and not going to go on both sides. And I'm going to come down like yay deep, right? Then I'm able to grab these and flow them. So I think a lot of people use this workflow, right? So let's flow along surface, flow along surface. Let's grab that corner of that surface and this corner of the surface here. And then if you look in ghosted viewport, you've got this huge thing sticking into the ring. All right. For the rest of this, I'm going to delete this surface. I'm going to explode here and delete this outside surface. So you can see what this means, right? So really what's going to happen, the metal is going to come flowing through the inside here, and it's going to see these thin items in its way, and the metal is going to be jetting in straight through the bottom. It has to come through at insane velocity, and on its way through, especially things like the 7, on its way through, it's going to just break this M away, all right, or pieces of this M away. And then what's going to happen with that M? It's literally going to go flying around, or pieces of it are going to go flying around the setting, and they're going to end up somewhere here. Let's say a little piece like that, and so that little triangle will be stuck on the surface of the ring, on the outside or the inside in powder. After the casting is washed, it becomes a hollow, and then you see this weird rectangular or weirdly shaped item on the surface of your ring, somewhere on the surface of the ring, right? Technically, that's breakaway. It isn't porosity. A piece of the ring somewhere else, or a feature of the ring somewhere else, broke and went flying around the casting, all right? Currently, that's the number one cause of miscasting. All right, actual porosity as porosity is minor. All right, so I'm going to go Control Z a few times to get back to our ring, and let's talk about how to improve that. All right, so this is not the right way. So let's go to the right way. I'm going to grab these guys. You want to take that measurement that we got before, Okay, so this is, I would call a bare minimum to improve your casting. And you want to extrude them to half of 0.47. And that's easy enough to do. You can just hit extrude, get your mouse in the side view down, and you go 0.47 divided by 2 and press enter. Now, when you flow this item, there's a far lower chance of breakaway. So let's grab that again. Let's do a flow along surface, flow along surface from this corner to, I don't know, let's put it there again. All right, so the intrusion into the ring is very low. It's still more than ample for you to do a cleanup and still have a hallmark left. All right. Now, if you want to go deeper than that, the next part is even better. All right, so grab the 750 that we're going to put inside there. And this is just a standard command, right? So you're going to do the same extrude, except you're going to continue typing extrude tapered. Okay. Extrude curve tapered. This guy over here. All right. Pull it in a down direction. Set your draft angle to 20. All right. So the strongest shape in nature is, well, technically it's a circle, but thereafter it's a triangle, right? And a triangle shape can sustain a lot more damage than any other shape. So zoom into where you've got very close stuff, and then just keep pulling your mouse down until you see where that 5 is failing. If you look in the top view, that 5 kind of starts not being okay. You get down to there, and you see what happened. You notice what happened? You're pretty much at the same depth. So this way you really can't go too deep. And this is super strong because it has tapered walls. All right. So this over here, when you flow it in, it also looks nicer. All right. I guess that's an opinion, but so let's grab these guys. Where are they? Let's delete you. And let's flow these guys along from here. Oops, see, not flow along surface. My bad, early in the morning. Flow along surface. And let's go from this corner to, let's put the 750 on this side. Okay. I got it back to front. Oh, no, I didn't get it back to front. I'm facing back to front. All right, so let's do the Booleans now. Let's take our surface. What I normally would do with these surfaces, right? After you've made this once, grab your surfaces and grab your constructions and put them on another layer and save this file as hallmarks. And then you're able to quickly bring it into the next file and just reflow and reflow and reflow and reflow and reflow the whole time. It's a very fast process for getting your hallmarks into a ring, right? Anyway, for the purposes of this, I'm just going to delete for now and dump all of that, and we'll do our Booleans. So this would BD for Boolean difference with you and you and you. Okay, so let's dump that. I got 2 rings. Okay, so you got the PJM inside there. It's still very, very visible. It's still very usable. There's no issues with that, all right? And there's far less chance that it's going to break away. So let's have a look at this one. Let's go Boolean difference with all of you guys. Okay, and then we delete this and we dump the main poly surface. Which one is the main poly surface? All right, so this looks nicer. It looks cleaner because it looks like it's been engraved by a tool because it has those tapered walls. So you've got a huge advantage here. It looks better. It's stronger, far less chance of breakaway, even less chance of breakaway than this. And this has got less chance of breakaway than the previous one, that deep one that was inside there. All right.